Okay, here we are, quarter 4, week 3, day 4. Find the quotient. We are dividing fractions. We are going to keep change flip. All right, so we have 8 over 10. Change this to a multiplication sign and flip this to 4 over 1. Again, that's called the reciprocal or the multiplicative inverse. All right, is there anything we could do to cross reduce first? Well, nothing with the 8 and the 1, right? That's as good as we can get with those. How about with 10 and 4? Yeah, we can divide 2 into both of those. 2 goes into 10 5 times. 2 goes into 4 twice. 8 times 2 is 16. We have 16 over 5, right? So how many times does 5 go into 16? 5, 10, 15, 20. That's too many, so 3 times, right? 3 times 5 is 15. We've used up 15 of the 16, which means there's 1 left in the numerator out of 5. So our answer is 3 1/5. All right, so Emma is practicing a back handspring, okay, in gymnastics class. She does it perfectly 8 out of 12 times. What percentage did she do it perfectly? So, all right, so how many times did she try? 12 times. How many times done perfectly? 8. So what percentage? All right, so it's like if you take a test and there's 10 or 12 total questions and you get 8 of them right, what will we do? We just take the 12 and divide it into 8. We take the bigger number and divide it into the smaller numbers. So we just do 8 divided by 12, and that gives us a repeated decimal of 6. So 0.6 forever. So if that was the case, we can actually just make it 0.67, because if we round it, the next number is going to be 6, which is 5 or above, which would make it 67%. Okay, so the other thing we could have done, okay, because so if we can simplify 8 over 12, 4 goes into 8 twice, 4 goes into 12 3 times, 2/3, and that's kind of one of the fractions that we try to tell everybody. 2/3 as a decimal is 0.6 repeated forever. So it's like 1/3 as a decimal is 0.3 repeated. So that would make it really, really easy as well. So regardless, we got 67% no matter which way we do it. List 3 values that would make this inequality true. And we know it's an inequality because there is a less than sign right there. The little line underneath it means less than and equal to. All right, so let's solve this by getting the y by itself, because that's what we always have to do to solve for a variable. Just get the variable by itself. So we have a 24 plus y. So what number do we got to get rid of? 24, right? We have to get 24 away from this side of the inequality, so we only have a y left over there. All right, well, what type of operation are we doing? It's addition. So what's the opposite of addition? Subtraction. So we're going to subtract 24 from 24, and we're going to do that to this side as well. That's what you have to do. So we have a positive 24 and a negative 24, which gives you 0. So the only thing left on this side is y. And then we have the less than or equal to sign. And then we have to subtract 42 minus 24, and that gives us 18. So now it's 18 is less than or equal to y. I like to always put the variable first. I think it just makes sense better when you're saying it out loud or saying it in your head, I guess. Either one. Okay, so you have to change it so that the wide part is still facing the y. So now if I say it, it's going to be y is greater than or equal to 18. So what are numbers that are greater than or equal to 18? Well, 18 is equal to 18, so that can be included. And other numbers that are greater than 18, well, it's 19, 20, 21, 22, 23, 24, 25, 29, and 107, just to be silly. All right, so as long as the numbers are larger than, greater than, or equal to 18, they can be on these lines. All right, that's all you have to do for that one. A cell phone measures 10 centimeters long, 6 centimeters long and 2 centimeters high. All right, I think they meant to say, first of all, for the length, then the width, and then the height. Okay, so that's what I mean, or that's what I think it is, because they're looking for volume, and volume is length times width times height, right? So all we have to do is do 6 times 10 times 2. Well, what's 6 times 10? That's 60, right? And 60 times 2, well, 6 times 2 is 12. Then just add the 0 onto that. So it's going to be 120, right? 120 centimeters cubed. Okay, so that one we could pretty much do in our head because the numbers were pretty easy to work with there. So 120 centimeters cubed. Each night, Emily gets math problems for homework. This week she got, she got 12 problems on Monday, 18 on Tuesday, 15 on Wednesday, 24 on Thursday, and 30 on Friday. So it kept going up, 12, 18, 15, 24, and 30. All right, so what is the mean? Well, how do we find the mean? Remember, the mean is the one that's is the average. So you can add up all the numbers, right? And there's 1, 2, 3, 4, 5 numbers. So you're going to add up all the numbers, and then we're going to divide it by 5. Okay, so that's how you find the mean. The median is the number in the middle. So what would be the median of this data set? Right, it would be the 18. And then the mode is the one that happens most often. Is there a mode in this one, or what number would be the mode? In this situation, there is no mode. Okay, so with this set of data, okay, there is no mode. Okay, and then the range would be 30 minus 12. So 30 is the highest number, minus 12, which is the lowest, so the range is 18. But we need to find the mean, right? So we have to find the average. So we're going to do 30 plus 24 plus 18 plus 15 plus 12, and that's going to equal 99. So we have 99. So we're going to do 99 divided by however many numbers are in the data set, which is 5. No, 99 divided by 5 is 19.8. Okay, so our mean in this one is 19.8. So we add them all up, divide by 5. That's how we get the mean. Right, it says find the mean absolute deviation. All right, well, let's find the mean first. So we have 1 plus 4 plus 7 plus 8 plus 10. That gives us 30. Right, so to find the mean, we're going to do 30 divided by however many numbers are in the data set. 1, 2, 3, 4, 5. Okay, so we have 30 divided by 5. Okay, so 5 times what is 30? We should know this answer. 30 divided by 5 is obviously 6, right? 6 times 5 is 30. So our mean is 6. So now to find mean absolute deviation, we're going to do 6 minus 1, and then 6 minus 4, and 6 minus 7, and 6 minus 8, and 6 minus 10. Okay, and then we got to find how far away each one of these numbers is from 6. Okay, what's 6 minus 1? Well, that's 5. 6 minus 4 is 2. 6 minus 7 is a negative 1, but we're just going to put 1. 6 minus 8, again, is a negative, so we're just going to put 2. 6 minus 10 is 4, but we don't care, again, whether it's positive or negative. We just want to find out how far away. Okay, so then we have, let's see, 5 and 1 is 6, 4 and 2 is 6, that's 12, 13, 14. So we have the answer of 14, but to find the mean absolute deviation, we have to do 14 divided by 5. So we go 14 divided by 5 equals 2.8. So there's our mean absolute deviation, 2.8. So basically you take 6, which is our mean, and if you go 2.8 higher or 2.08 lower, okay, that would be a very safe number that would be very likely to be in that data set. So that's mean absolute deviation. All right, place a 5.9 on the number line. Okay, so there we go. We have between 5 and 6. It's broken into tenths. Okay, so this would be 5.1. This would be 5.2, 5.3, 5.4, 5.5, 5.6, 5.7, 5.8, and 5.9. The next one will be 5.10, which just makes it move it up to a 6, right? So to plot that one, we want it at 5.9. There we go. We are finished with that one. Graph the ordered pair -3, -2, and its reflection over the y-axis. Okay, it keeps wanting us to reflect over the y-axis. All right, so here we go. We're going to start right there at the origin. Okay, that's where you start on a coordinate plane. We're going to go -3. So if we're going left or right, do we go to the right or left if we're going to go negative? Yeah, we're going to go to the left. 3 places. 1, 2, 3. Okay, so then we're going to go -2. So if we're looking at the y-axis up and down, which way is negative? Up or down? Yes, it is down. So 1, 2. So there's our plot. -3 and -2. Now we need to reflect over the y-axis. So we're going to go 1, 2, 3 places to get to the y-axis. So we have to go 1, 2, 3 this direction. And we are going to plot that right there. Okay, so that's how we get that one. We plotted -3, -2, and we plotted its reflection across the y-axis. Compare with greater than, less than, or the equal to sign. So we're going to use one of those 3 signs. So we have 1/9. Okay, so we have 1/9, which is going to be less than 1, right? So 1/9 of something is less than 1. Okay, but it's going to be like 0.11111 repeated forever. Okay, so, but it's a positive number no matter what. It's a positive number. And then the -4 is a negative number. So obviously -4 is going to be further to the left on the number line. And if that's the case, then -4 is going to be the smaller number between 1/9 and -4. So we're going to put the sign this way because 1/9 is positive and this is negative. So the positive number is obviously bigger than the negative number. So 1/9 is greater than -4. Okay, so down below here, both of these are subtraction or are negative numbers. So now we have to think which one is further to the left. That's going to be the smaller number. So we have a -0 and a -2 in the ones place. So think about it. -0 is just going to be barely to the left of regular 0. Just not a negative at all. Okay, but -2 is going to be 2 places plus a little bit more further to the left, which means the -2.3 is the furthest to the left, which means that is the lower of the 2 numbers. So -0.43 is greater than -2.3. All right, there we go.